Hello everyone, I'm Cameron. I'm a geology tutor here at Fresno City College. And as you can see here, we have some rock samples out here. So today we're going to look through the various rocks that you'll need to know for your rock exam if you're taking Geology 1 from Mr. Poole. So here's just the igneous rocks. We're going to go ahead and start with these. So here you can see we have a mafic rock because it's dark in color. So the composition we would say is mafic. The texture, we don't see any crystals visibly, so we'd say that's aphanitic, which tells us additionally that it's a volcanic rock. So a volcanic mafic aphanitic igneous rock, that would be basalt. Okay, next we'll be looking at this one here. So here we see an intermediate composition. It's not quite as dark as our basalt, and it's not quite as light as something like this rock here, which we'll get to. So we say it's an intermediate composition. We also say that the texture would be aphanitic because, again, we don't see any crystals. If we take a look here, it's a very uniform looking ground mass. There's no visible crystals to us, so we say that it would be an aphanitic texture, which again would say it's volcanic igneous rock. So volcanic intermediate aphanitic igneous rock would be andesite. Okay, back here we can see we have a plutonic igneous rock because it's phaneritic in texture. We don't see, or we do see crystals. Okay, we can see quite a mixture of crystals here. The composition we would say is felsic because it's very light, and so we have plutonic, felsic, phaneritic igneous rock, which would be granite. Okay, we come down here now. We have another igneous rock here. This one would be volcanic because it has an aphanitic texture. Again, you can see that we don't have any visible crystals here. The composition would be felsic because it's, again, very light. So we have a volcanic felsic aphanitic rock, which is called rhyolite. Okay, moving up here. Here we have another mafic igneous rock. Okay, and this time, if you look closely, we can actually see some crystals. Okay, it's a little hard to tell since everything's so dark, but if we move it around, we can see those crystals. We can see the luster shining back at us there. Okay, so that would mean it's a phaneritic texture, which indicates it's plutonic igneous rock. Okay, so it cooled slowly under the ground. So a plutonic mafic phaneritic igneous rock would be gabbro. Okay, so behind it, we can see we have this rock here. If we look at it, we see a very mixed composition. We see a lot of felsic-looking crystals, but we also see almost an even amount of mafic-looking crystals. We can say that almost looks like a salt and pepper composition, and that would actually be, again, an intermediate rock. Okay, the texture, since we can actually see those crystals, is phaneritic, which tells us it's plutonic. So a plutonic intermediate phaneritic igneous rock would be diorite. Okay, coming down here now, here we see green crystals. We see olivine here. Okay, so that should be really the giveaway for this rock, is that we have that olivine. That olivine indicates that it's actually ultramafic, okay? And since we can see those crystals, we know that it's phaneritic, okay? Which, again, would indicate that it cooled slowly under the ground, so it's also plutonic. So we have a plutonic, ultramafic, phaneritic igneous rock, which would be peridotite. Okay, moving up here, we have this rock here. The composition would be mafic. It's very dark. And if you look closely, you can actually see we have a lot of vesicles here. Okay, so the texture, with all these holes in it, otherwise known as vesicles or cavities, the texture would be vesicular. Okay, which would indicate that it cooled very fast on the surface, which would be volcanic rock. So we have a volcanic, mafic, vesicular igneous rock. That would be scoria. Okay, behind it, you can see we have this rock. It's very light, so we know the composition would be felsic. If you look closely again, you can see a lot of little vesicles, a lot of little holes, which would tell us that the texture is vesicular. So vesicular texture again indicates that it's a volcanic rock, cooled very fast on the surface. So a volcanic, felsic, vesicular, igneous rock would be pumice. Okay. So we also have this rock here that you guys will need to know. And so you can see here, this rock overall has a very dark color, but we need to be careful on this one because despite the fact that it's very dark, it's actually felsic in composition, okay? So just remember that one's a little tricky. It's very dark, but it's actually felsic, okay? And the texture is glassy, okay? We can see how shiny that is. It almost looks like glass, okay? And another unique characteristic of this particular rock is that we have this conchoidal fracture, okay? You can see how we have these lines coming across here, just like a conch shell. So we say that's conchoidal fracture. Again, the glassy texture means that it cooled extremely fast, and so we would say it's a volcanic, felsic, glassy igneous rock, which would be obsidian. Okay, I'll put that right there. Okay, finally, we have this rock here, and while overall the texture would be considered probably porphyritic, it's a mixture of sizes. If we look closely, I want you guys to focus on the orthoclase here, this pink mineral. We can see those orthoclase crystals are actually quite large, okay? And so those size crystals would be indicative of a pegmatitic texture, okay? So those large crystals would indicate a pegmatite, and if we had these crystals in a felsic rock, we'd say that it would be a plutonic, felsic, pegmatitic igneous rock, which would be granite pegmatite. Okay, we don't have an exact example of granite pegmatite right now, but if you look for those large crystal sizes, it should be really easy to spot. Okay, so we have our granite pegmatite. Again, look at those crystal sizes. It's one of the easier samples to look at or to identify, and so we have our granite pegmatite. All right, thanks for watching the igneous rock section.